Now we are going to discuss about the terms. For that, you need to be aware of few things. Uh, I took one spear, I cut that into the half. I cut that into a half, and if you take it or put it in a proper way, you can see that as a circle, not a three-dimensional semicircle. But if you just turn it and put it, you can see a circle. And you know how what are the parts of a circle? In the center of the circle, you can see the center. Yeah, in the middle of the circle, there will be a center, and this the distance from the center of the circle to any point, you can switch that point any point. There are infinite points, so that distance is called radius. That distance from the center of the sphere to any point. I marked only this point here. You can mark it here, 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 anywhere. Infinite number of places on this boundary. I am talking now about two-dimensional. Now, if we make it into a three-dimensional image or a three-dimensional shape, how does it look like? Now, here you can see the radius is from center to any point. Now, if you take a hollow sphere and put a small cam inside, the center of the sphere is this, because as I told you, that's a semicircle. I told you I cut it into a half, a three-dimensional semicircle. And the distance from here, I'm talking about from inside, I cannot draw inside. So, I'm showing you the distance from here to here. This is dotted line represents that is inside. Yeah, here. That is also the radius. It means for a circle only this is radius, but this is three-dimensional. There will be depth also, so it will go back like this. It will go back, means inside. That's it, just inside. That's the only way I can tell you the distance from the center of the sphere. I am talking, not circle. I am talking about sphere, not circle. Sphere. From the center to any point, that is called radius, and that point is called center. Now that is, these are the terms we use commonly for a circle. Na circle, for circle we use these terms, but this is something special, three-dimensional circle, another type of circle. For that we use some additional terms, that is center of curvature, radius of curvature. That is the only difference. This is three-dimensional, and for a circle it is two-dimensional. Next, I told you we are going to name these points different points. Now think, if there is a mirror, or especially a spherical mirror, it contains infinite points, but there are some special points. They are very special. You know why? I'm going to tell you why. Yeah, those are pole, center of curvature, radius of curvature. Radius of curvature is not a point, it's a distance. Focus and principal axis. Principal axis is just a line, as you can see, a line. Now I'm gonna show you, I'm gonna tell the significance of all these terms. The first one is gonna be the pole. Pole is the center or the middle point of what? Of this reflecting surface. Mind it, reflecting surface. Now here this is all opaque. Remember, this is all opaque. Here nothing will be, no reflection can be seen. And similarly, here there will be no reflection. So the center point of this is called the pole of the reflecting side, reflecting surface. Because this is a two-dimensional drawing, I cannot show you, I cannot turn it, I cannot flip it. So the center point, it is not this, but if you turn this you can see it like a circle, and here that is this point is called the pole. It is three-dimensional, so I can't show you. Now it actually looks somewhat very somewhat like this. Next, pole is done. What is pole? The center point, or the point located at the center of the reflecting surface of the mirror. If I ask you something about pole, suppose in your exam a question may come, a 2 mark question may come, define pole, then you should never think of it. Simple. If I wake you up from the sleep and ask also, you need to tell. I'm not telling you to mug up. I'm telling you to understand the terms. Understand. Never try to mug up. This will give you a great knowledge. Remember me. This type of mirrors will fetch you a lot in your future. Even in your grades 10, 11, and 12, there are a lot of topics based on these. So be careful. Just think practical. Never mug up. Okay. Now come back to the topic. Paul. Yeah, I told you, na, the center, or this point located at the center. In that infinite points, there are infinite points. In that, I am talking only about one point located at the center of the reflecting surface. Next, I told you that these mirrors are parts of a sphere. I showed you a sphere also. This is a sphere you can see here. And in this sphere, there is a point located in the center of the sphere. This point. This is called the center of curvature. Specifically, if you want to be the distance from the center, the point located at the center of the reflecting surface, or not reflecting, the sphere for which the spherical mirror is a part of. See, actually this is just cut out. The sphere is, this is the sphere. The originality, or the origin of this mirror is this. And what is the center of this? Center of curvature, this one. From here, if you measure the distance from the pole, that will be equal to any of the distance I am drawing, any of the distance from the point. And this distance is called radius of curvature. So we discussed about 2 points. Yeah, center of curvature, radius of curvature. The distance from the center of the sphere to any point on the surface or the boundary of the sphere is called radius of radius of curvature. Now if we are talking about mirror specifically, then the distance from center of curvature to the pole of the mirror. Why I'm talking about pole? Pole is also a point. Now it's just a special point. We all know about latitudes. Why are we naming Tropic of Cancer, Tropic of Capricorn? Even they are latitudes, but they are something. They have something special. They have some significance. Even same with the pole of the mirror. Just a point in infinite points. That is the pole. The distance from the center of curvature to the pole is called the radius of curvature. Did you get it? Yeah, you will get it. Okay. Now, focus. What is focus? Now about Focus. What is focus? To tell mathematically, the focus is the half of radius of curvature. The point located in the midway of radius of curvature. That is focus. If you can see, what is the radius of curvature? We know the distance from this point to this point. If we cut that into half, that point located at that half is called the focus. And to tell this, no, I'm talking about focal length. I want to talk about focal length. The distance from the pole to the one point to the other point, one special point to other special point also should be named. So one special point is pole, another special point is center of curvature. The distance from the two is being named as radius of curvature. Now, next pair of special points I'm going to discuss. Now, the pole, one special point, focus, another very special point, and the distance from them, the distance between them is called a focal length. This is what you need to remember. The difference between radius of curvature, center of curvature. Remember, center of curvature is a point located at the center of the sphere. Radius of curvature is what you told, a point at the center of curvature to any point. We are talking specifically about some signified points. So now we can tell that is pole. Okay, the distance between pole and the focus is called what? Focal length, because focal, focus, focal length. And these three are special points. Now, I think let me draw a straight line. Let me draw a straight line passing through them. And these 3 points are special. I thought these 3 points are special now. Then this my line is also special, and I thought I'll name. Why don't I name? There are very great names. Pole, center of curvature, radius of curvature, focus for these points. Why don't I name my line? I thought to name that as principal axis. You can see principal axis. Or to define that, the line passing through the center of curvature and the pole of the mirror is called the principal axis. Or to be more specific, the line passing through the center of curvature to the pole via or through the focus of the mirror is called the principal axis. Now to tell what is focus, F is equal to R by 2, or R is equal to 2F. This goes here, this goes here, so that will be equal like 2F. Now, we talked about different parts of a spherical mirror. The pole is the point located at the center of the reflecting surface. Center of curvature, the point located at the center of the sphere. Remember, they might ask a difference between the pole and center of curvature. Tell the answer, or tell the difference in one sentence, and you should be able to answer it. It is the point located at the center of reflecting surface only, not the sphere. Remember, reflecting surface, not sphere. If it comes to sphere, that is called center of curvature. Okay, the third definition. The distance between center of curvature and the pole of the mirror is called radius of curvature. The distance between the center of curvature of the mirror and the pole of the mirror is called radius of curvature. Next coming, we discussed about a pole, we discussed about center of curvature, we discussed about radius of curvature. Now we are going to discuss about focus. What is focus? Just focus. First focus, and I'll tell you about focus. Here, the point located midway between the pole and center of curvature. The point located midway between pole of the mirror and the center of curvature of the mirror is called focus. Focal length. What is focal length? The distance between pole and the focus of the mirror. The distance between the pole and the focus of the mirror is called focal length. And principal axis, the line passing through the three special points. You should never write three special points. What are those special points? Center of curvature, focus, pole. Those three should be mentioned, mind it. And if there might be a question asked in your examination, uh, this might not be of great significance or a great marks, might not be allotted because this is a very simple question. You should answer it. They'll ask you or they'll give you the question as the focus or the focal length of a mirror. The focal length of a mirror is equal to 3.5, and they will ask you to find the radius of curvature. Radius of curvature is equal to what, they'll ask. Then what you do? You know that focal length is equal to r by 2. Focal length is equal to r by 2. 3.5 is equal to r by 2. And r is equal to 7. And full marks for answering it. And every step is important in this. You should never miss any of the steps. Okay, remember, you should never miss any of these steps. And a pretty reverse question might be asked to you. They'll give you the radius of curvature. Radius of the curvature of the mirror is equal to 3.5 only. I'll take just a complete inverse of it. You're gonna do now. F is equal to what, they'll ask. Now F is equal to R by 2 is equal to 3.5 by 2. That is going to be equal to 1.75. And the units, whatever they give centimeter, you need to mention centimeter. If they give meter, you need to mention meter. But SI unit of focal length, SI unit is always meter. Anything about length, it's always meter. Remember that. And I want to tell you about these three special points. Do you know about virtual and real? The image formed by a plane mirror is virtual. Why it's virtual? Because the reflected rays are never gonna meet again. Once they get reflected, they are gonna go in different directions, completely different. They never meet. That is why the image is never formed, or the real image is never formed. What our eye thinks is, it thinks that all that is coming from a point behind the mirror. That is called a virtual image. That is called a virtual image. It means like in a ray diagram, if you want to tell, that is what this is, a plane mirror. And if one ray is coming like this, hitting here and going away, and another ray coming, hitting and going, These are from one single source, and what happens, these are gonna never meet here because they are y. They are divergent rays. Divergent beam, I told you in the beginning of this video, they are divergent beam. See, simple. This is one mirror, one ray hitting, going, another ray hitting and going. If you drag them back somewhere over here, they'll meet. They appear to meet to our eyes. It means a virtual image always fools our eyes. Our eye is always fooled by a virtual image. For a real image, I'll show that here. This is one ray, this is another ray, and the reflected ray will be like this because the angle of incidence is equal to angle of reflection, and the same here, it will be like this. Here you can see they are meeting, but here they are never meeting. Remember, they are just going away like this. They are never gonna meet. They are gonna meet where? At infinity. So infinity is undefined, so we consider that they'll never meet. That's it. Now you know the difference between a virtual image and a real image. Now these points are there in the side of or are there in the side of the incident, the reflecting surface? Yes, because they exist for this mirror. Really, they exist. Really means not that really. Uh, they are real. But for this convex mirror, they are virtual because they are not, they appear to be here, but they won't be here. They appear to be. Suppose if I draw the same thing for this, it will be like this. This will go here, and it will be like this, and this will go here, and I'll push them back somewhere, some like this, like this, like this. They meet. That's it. They appear to meet here. So they are just virtual for a convex mirror and real for a concave mirror. And the images, how the image will be formed by concave mirror, how the image will be formed by convex mirror, I'm going to discuss in detail in the later sessions. And thank you for watching. Hope we educated you about this topic. If you have any queries, doubts, please you can mail your doubts to educate.satish@gmail.com. Remember, educate.satish@gmail.com. Please feel free to share any suggestions or comments about this video, and you can also post them down in the comments. If you want to get notifications about our latest video, please do subscribe and click the bell icon. And if you want any requests from you or any suggestions from you, please feel free to share them. They are completely encrypted. No one is gonna see. Thank you for watching this video. Hope we are gonna educate you with this. Any doubts, please post to educate.satish@gmail. Please post. And any suggestions also you can. Thank you.